The next big derivative rule that we're going to talk about in this section is the derivative of f of x equals natural log of x. And if I take the derivative of natural log of x, I'm going to end up with f prime of x equals 1 over x. So this is one that we'll be using really pretty often for the rest of this course, along with the derivative of e to the x that we talked about in our last video. This is definitely one that you're going to want to have memorized as we go forward. Now, in order to make full use of this derivative rule, we do need to review some logarithm properties here. Hopefully these look somewhat familiar either from college algebra or whatever your last math class was, but just in case we need a refresher here, if I have natural log of a times b, I can split that up into two separate logarithms to say that's natural log of a plus natural log of b. Division works very similarly. If I have natural log of a divided by b, I can split that up into natural log of a minus natural log of b. And my last logarithm property is a little bit trickier. It's natural log of a to the p power. I can rewrite that exponent p as a factor, so I can rewrite that as p times natural log of a. And the reason that we'll need these is if I look at this derivative rule, this is really only going to work for me if I have the derivative of, say, natural log of x. If what's inside of that natural logarithm is more complicated than just x, let's say I had natural log of x squared. Well, I don't necessarily know how to do that. I would need to use some of these log properties to help me find this derivative. So we're going to look at some examples here where we're going to practice using these logarithm properties to simplify our function first, and then we'll be taking our derivative. So for our first example, we have y equals 10x to the third power minus 100 natural log of x. Well, when I go to find my derivative, y prime, the derivative of 10x to the third, well, that's just a regular old power rule, so that'll be 30x squared. Here's where the new stuff is happening, minus 100 times natural log of x. Remember this minus 100, this is a constant multiple, so we're multiplying by that negative 100. So how we're going to deal with that is we're going to take the derivative of natural log of x first. The derivative of natural log of x is 1 over x. And then we just multiply that derivative by our constant multiple. So we'll multiply that by negative 100. So I really have 30x squared minus 100 times 1 over x. Well, I don't really think that second term looks particularly nice. I'm going to rewrite this as 30x squared minus 100 divided by x. I think that just looks a little bit nicer. So here we just had natural log of x by itself. We didn't really have to simplify anything here. My next example, though, I've got y equals natural log of x to the fifth plus e to the x plus natural log of e to the third power. Now, before I can actually go to find my derivative here, it's this x to the fifth power that's going to be causing me a problem because I have that x to the fifth inside of my natural log function. So in this particular case, I'm going to have to make use of that third logarithm property. It says I can take a power and rewrite it as a factor. So one thing I'll say be careful of, this maybe looks similar to the power rule for derivatives because we're multiplying by the power here, but we're not actually taking the derivative here. We're just rewriting the logarithm function. So after we simplify it, we're still going to need to actually use our derivative rules. So I can rewrite this. So this is still going to be y. It's not y prime. I can rewrite this power as a factor. So I can rewrite this as 5 times the natural log of x plus e to the x. Well, we know how to take the derivative of that from last time. That's just going to be plus e to the x. And natural log of e to the third. This one is a little bit tricky. in that we don't really have an x here to deal with. And I'll kind of give away the ending here. This actually ends up being a constant. If you don't have a multiple of x or a power of x, if it's just natural log of e to the third or natural log of some number, that's going to be a constant. And we know its derivative is 0. We could leave it as natural log of e to the third if you wanted to, or you could actually grab your calculator and type that in. You could also use what you know about logarithms. If the logarithm base is the same as the base of the exponential inside of it, those two are going to cancel, and I'll just be left with plus 3. So if you want to simplify that, you can. I think it makes this next step easier when I take the derivative to recognize that this is a constant. But if you wanted to leave it as natural log of e to the third, you could do that too. So notice this is still y. This is not y prime or dy over dx. So okay, I still need to take my derivative. So y prime is going to be 5 times the derivative of natural log of x. Well, that's 1 over x. Plus the derivative of e to the x. That's e to the x. And the derivative of 3, well, that's just 0. So again, let's just clean this up, make it look a little bit nicer. 5 times 1 over x. This is really 5 over 1 times 1 over x. So if I multiply my numerators together, 5 times 1, I get 5. Denominators, 1 times x, I get x. 5 over x, and then plus e to the x. There is my derivative. So we will need to just keep an eye out for what's inside of that natural log function, and remember that we have those log properties to simplify what's inside of a logarithm. Part C right here, I have y equals x to the fourth plus natural log of 7x. So this time I don't have x to some power, this time I have a constant multiple of 7. So again, I'm going to need to make use of those logarithm properties. If I scroll back up and take a look at them. Here, I'm going to have to make use of this first logarithm property. This says natural log of a times b, so I can think about that as 7 times x. Well, I can break that up into two separate logarithms. That's natural log of 7 plus natural log of x. So I'm not going to take the derivative here. This is still y equals x to the fourth plus, when I break this up, it'll look like natural log of 7 plus natural log of x. Now this is in a form that's much nicer to work with. I can take the derivative of this. So y prime x to the fourth, well, that's going to be 4x to the third power. Derivative of natural log of 7. Be careful here because we don't have an x. Natural log of 7, this guy right here, that's actually a constant. You can type that into your calculator and see what that is. It's going to be some ugly looking decimal, but it's going to be a constant, and I know that the derivative of any constant is 0. Plus, for my last term, derivative of natural log of x is 1 over x. So this is really 4x cubed plus 1 over x. And there is my derivative. Our last example that we have here, we've got y equals 8x to the fourth power minus natural log of x divided by 5 minus 9 times e to the x power. So again, what's inside of my natural logarithm is a little bit more complicated than just x. In this case, it's x divided by 5. So I'm going to have to make use of my logarithm properties one more time. And this time around, it's going to be that second logarithm property. I think this one's a little bit easier to see because we can see that fraction. So I can split this logarithm up into two separate logarithms, and I can say, well, that's natural log of the numerator minus natural log of the denominator. So I'm going to write this as y equals, again, this is still y, not y prime, so this isn't the derivative, 8x to the fourth power minus natural log of x. And if we go back and look, when we split this up, we're going to have a minus sign in between them. So minus natural log of 5 minus 9 times e to the x power. And I will point out here that I actually have a mistake in what I've written here, because when I break up this natural log into the two separate terms, I am going to have to distribute whatever constant multiples I have out here. Here in this case I've got that minus sign. It's really a constant multiple of a -1. The way that I think would help you do that is to kind of think about this as being inside of parentheses, so that when we break it up, we still have those two logarithms inside of parentheses. And now we can see, oh, okay, I need to distribute that negative sign to both of these two terms. So let's simplify this one more time real quick before we find our derivative. This is y equals 8x to the 4th power minus natural log of x plus natural log of 5 minus 9e to the x power. So now when I go to actually find my derivative and find y prime, we should be good to go at this point. The first term, we're just going to use our power rule, so that should look like 32 times x to the 3rd power minus derivative of natural log of x, well, that's just 1 over x. Natural log of 5, just like natural log of 7 was last time, this is a constant, so its derivative is 0. So I'm not going to write the 0 this time. And then for my last term, derivative of -9e to the x, well, in that case I just multiply the derivative of e to the x, which is e to the x by -9. So my derivative should look like -9 times e to the x. And there is my derivative. So both the derivative of natural log of x and the derivative of e to the x are functions we're going to see really often going forward, so it is going to be really important that we have both of those two derivative rules memorized for the rest of this course.